All right, we got a good one here today. This is one of my students' vehicles. This is a 2014 Subaru WRX, and this is not the STI. He installed a new downpipe, and now we have some oxygen sensor codes, and that's what we're doing here is we're addressing a downstream O2 sensor fault. So let me show you what the trouble codes are. You see we have a bank 1 sensor 2 heater fault, both of these, this P0141 and P0037. Bank 1 sensor 2 is downstream. When you see sensor 2, that is a downstream sensor, and that matches our concern. We put this downpipe in, you had the sensor out, and our concern was just disturbing the sensor. So with that code, the next thing that we did is we went over the diagram together, and I want to show you guys that now on paper. All right, so what we did is we started at the sensor, and our concerns for this were which wire is the heater circuit, which wire is the signal circuit. Some tips that we used along the way is our shield right here. We have a shield wire that is tied into here, so the shield tells me that this is the signal wire. So my pink wire, for sure, no question about it, is my O2 signal wire. That pink wire, if you follow that, it comes over to my engine computer right here, and there's no designation for that. How important is it in a case like this when you're dealing with a wiring diagram with no designated writing in here? So it doesn't say like O2 signal, to know that that's the signal wire for the O2, and that's not our main concern, is that wire. That shield was key. The second part we said was because the shield ties into this wire right here, that suggests that this wire is a ground. So then we followed this wire, and what we found, I have it highlighted green, is it ties into the pressure sensor. It says pressure sensor. That's a vacuum pump. There's a pressure sensor in this vacuum pump. It ties into the mass airflow. This big splice is where the tie-in was for the O2. Ties into the accelerator pedal position and then goes to the engine computer. So we thought that maybe that was the heater ground for the O2, but what tells us that's not the heater ground? We know it's a ground because grounds are shared between sensors. We thought it was the heater ground at first, but what says it's not is you would not pump heater ground current into this circuit. So what that means is that is most likely our signal ground, not the heater ground. Why are we so concerned about which ground is which? We need to check the heater ground. Some other things we talked about as far as knowing that this was a ground wire was really the shared sensor here, this pressure sensor, and the potentiometer that's in the accelerator pedal position circuit tells us that this is going to be a ground. We share grounds between sensors. We can share references between sensors, but we don't send a reference to the O2. So using those truths, in fact, I told you guys we're going to be reinforcing that in section 9, the 5-volt reference circuit, section 7 and 8, when we do potentiometers and pressure sensors. We'll review that again, and that's what can be shared, what can't be shared. We're applying all of this knowledge. From there, what we've made the determination of is this circuit here, this blue wire, which is also shared with the other O2s. Let me show that again. This blue wire will be the next one that we're talking about, shared with both O2s. It comes up and goes to a relay up here, and what we found is this relay goes to a fuse, and I don't have that part marked. It's one of these fuses over here. So what we know about this blue wire is it is a switched power feed. So there's relay controlled. It switches power down to these two O2s. Both O2s get power at the same time. That is the heater power circuit. And so the heater ground, again, is what we were looking for. I went a little bit out of order that time, but heater ground, what we're looking for, we're saying it's not this ground because O2 heaters would draw on average 1 to 2 amps of current flow, and they're higher on the wide bands. And we're not going to flood a sensor ground with that kind of current flow. And that's what we're saying. Even though the blue wire is the heater feed, we're saying the green wire is not the heater ground because of that principle. So that has to be the signal ground. That's the signal wire. I have one left. This yellow wire that goes to the computer right here is what we're saying our O2 heater ground is. So it's computer controlled ground. And really we started with this trying to coach my student through doing voltage checks on his own. And what we would want to see on a typical heater circuit, just draw it here, would be on one side of the heater, depending on design of course, but on one side of the heater we want to see 12 volts, and on the other side, as long as it's being grounded, we want to see near 0 volts. That would be a working heater circuit. But this is computer controlled, so there is the potential that this driver, which I'll draw as a switch, is not going to be closed on startup. It may wait till the moisture burns off in the exhaust before it turns it on. So in that case, what we'll see is 12 volts here until the computer closes the driver, and then we'll see it drop to near 0. This is what we want to see when we check this. We're about to do it on this car. One other variable, if you're checking these at home and you do not have a scope, is you may check this wire and see 7 volts on that wire, and what you're going to think is you have a bad ground. But what you actually have going on that circuit is this driver is pulse width modulated, and it turns the circuit on and off to pulse it. And if it's a 50% duty cycle, you're going to see an average of that pulsing, which will be 14 high and 0 low, which will put you right at 7. So something else to consider if you were only using a voltmeter is voltmeters read an average. So again, with the codes on this vehicle, our main concern is the heater. We're going to check it for a 12 volt feed, and then we're going to check that control wire for either a pulsed signal or a steady ground, one of the two. Now I'm going to attempt to show you this. The wiring on this, it was rubbing on the drive shaft. We know what our problem is. We have a code. This was caused by when the pipe was reinstalled, that sensor lives in a little bit different of a location, and it was a little closer to the drive shaft, and it's rubbing on the drive shaft, so we won't throw you under the bus too bad on that. Dave, I just mentioned your name too. I could show you your face if you want. That's okay. So we think we can fix it, but our main concern is, well, one, to reinforce this stuff is good, and two, our main concern is, did we hurt the computer driver? Is it possible that we could hurt, if this is computer controlled, and we are correct in what we're saying, that this yellow wire over here, this yellow wire, it's a transistor, it's ground side switched. Is it possible when this wiring got messed up that we damaged that computer driver? I know for a fact that Dave is thinking right now, I hope not. Last Subaru computer I priced was around $2,000. So is it possible though, if this is a customer's car, is what we got to think about too. You wouldn't want to sell the customer an O2 only to find out later you have a $2,000 computer that's bad. So the stuff that we're going to do, this is in section 3, we're reviewing section 3 information in how to check a computer driver and how to check a computer output. That's what we're doing right now, okay? So what could damage that is if this blue wire, which is the O2 heater feed, and the control wire, which is the heater ground, so the blue and yellow, if these two wires touched each other in the process of them rubbing on the drive shaft, what potentially can happen is, instead of the power going down through the heater circuit of the O2 and then having resistance and going to the computer, it will bypass the resistance, go straight across, and send unrestricted current flow to the computer, which would cook that driver. And I'm not making this up. This is a real concern. We do not know yet whether or not this computer is damaged. I know Dave is freaking out right now. We're going to do this test. It's not that difficult to do. Here's where we're going to start. I'll try to get you underneath and show you the wires here too. But notice on the diagram, now I've drawn all over it, so we really can't see it. Right? I'll look at the upstream O2 so you can see the NCA. See where it says NCA? Can you guys see that? Right there? NCA, and then there's a connector. What does the NCA mean? It means no color available. When they give you sensor side colors, there's universal sensors, and the sensor side colors can change. Okay? So what we can see underneath the car is we see two blacks, a white, and a blue. This is a pretty standard sensor side color design. What's nice about this is if you know these, we can also know circuit design and what our heater, powers, and grounds and things are. And when you see two of the colors that are the same, whether it be two whites or two blacks or two browns, I've seen all of those, the two blacks are the heater circuit. They're not polarity sensitive. We're just passing current flow through and heating up the sensor. So I had Dave crawl underneath to check what we were thinking on our two blacks, that we did this right and we mapped this out right. Notice I put a little arrow here and here. The two blacks corresponded exactly with what we determined was the O2 power, which is here, the heater power, and then the heater ground, which is here. Dave, the two black wires are exactly these two. We did it right. This green circuit is definitely the signal ground, not the heater ground, so we're good to go. Whether we check this now on the black wires, which would be sensor side, or we check it on the other side, which I can't see, my eyes are not that good. What color is that? Yellow and what? Come here. Someone that's got better eyes than me. Actually, that says NCA, right? Mm-hmm. What's that say? Yellow, red?
Yellow, red.
So yellow, red, and then what's that one? White, black?
White, black.
So we have here's what we got. We got black that turns into a yellow, red. Okay? And black that turns into a white, black, correct? Depending on which side of the connector we can get to, those are the two wires that we're concerned about. What we're going to do is we're going to take that connector, and I'm going to try to show this. We're going to T-pin it. We're going to put a voltmeter on it to ground. We're going to use a scope, which is a very fast voltmeter. We're going to do two voltage readings first on those two wires. Now, keeping in mind, this is relay controlled, guys, that the power feed for the relay. We may have to run it for that relay to close to put power down there. In fact, I'm almost positive we're going to have this car running when we do this check. Okay, so this is first up. We're going to hook up underneath, check these two black wires for power feeds, see what we have, and we go from there. All right, so there's our downstream sensor, guys, and what we're looking at here for some perspective, this is the green conduit is covering for the harness. Right above that, that's the drive shaft for the rear. So you can see the damage in that. If I reach my hand around here, you can see where that was rubbing on the drive shaft. Now we stopped right here before we backed up and filmed this. We don't know where the damage was. Looking at the damage will help address whether or not we have computer concerns. So I could maybe do that live with you guys here. If only one of the blacks, looks like we have some busted wires here, don't we? Are those broken? Or is that, no, that's fibers from the green stuff.
Yeah, I can't.
Let me back up a little bit here. Can you guys see what we're doing?
Yeah.
I need to turn this around so I can see it. It's hard to look through a 2-inch camera screen. All right, we're going to do this a little bit differently. Rather than checking voltages with it plugged in, I'm concerned about the wiring. I want to unplug it. do this?
Clip's stuck. There we go.
Did you get it?
Yeah, I just had bad leverage.
Okay, cool. So what we'll do is we'll stretch this harness over here now.
Yeah, you can.
And we'll be able to tell a lot better any damage that has occurred. And all right, so we definitely have a break in this black. Hold on, let me get this out.
I can move too.
Are both blacks damaged? Is our question. If only one black is damaged, this being a ground side switch circuit, you're in luck, brother. Guys, I don't know if, can you guys hear me out there?
Yeah.
Can you see, let me try to get my camera still here, hang on. Pull this green, can you hold that down there? All right, so the blue wire is good here. The one black wire, you see the damage, guys? Yeah. It's actually broken all the way. The only thing that's holding that together is insulation. So this black wire, which is part of the heater circuit, that's why we're getting codes, is damaged. The other black wire, no damage at all. And the white wire, no damage at all. So it's just that one black wire. And the reason I'm saying we're in luck is it would take both black wires to be touching each other for that to happen, that hypothetical that I gave you guys. So your computer's going to be fine, but I want to show you guys a test anyway on how to check that black wire, the computer driver, and what we're going to do to test it. Well, there's a couple ways we can do it. We could fix this and then do our voltage checks and current flow, but what I want to teach you is using a test light, because what if you can't fix this right now? What if the sensor's damaged to the point where you cannot fix it and you need to make sure that that computer driver is good? So what we need to do is on the connector, we need to know the wire colors, which we already figured out, which are what? White with a black tracer.
Yellow and red.
And I'm over here. You guys aren't going to see this part. I'll have to change my camera angle. The one that goes to the computer, I believe, is white and black. We're going to want to back probe that on this back side. Move this up out of the way, and we'll go on the back side back here, okay?
All right.
And then I'm going to hand you a lead. We're going to back probe that, that circuit, and we're going to do a couple of checks on that. And I'm going to show you how to check that circuit with a test light. Guys, on that wiring diagram up there, the wire that I have going to the computer,
You can't back probe it.
No?
Like a grommet.
Oh. Will that grommet slide out of the way? Actually, we don't have to. We can.
If you know.
You do. I do. All right, here's the thing then. Can you identify at least the wire color on the back side?
Yep, white and
And
black.
do you know which pin that white black wire is?
Yeah, can I pin it? Can I
Yeah,
probe it
hold
with a
on.
pin?
Before you do that,
All right.
there's concerns with doing that.
Okay. Yeah, there's only 4, and I'm guessing.
Okay. Why is there a concern about misidentifying the pins?
No, I got it.
Okay.
Yeah.
All right. Can you show us the connector? That's still rolling, so just try not to push any of the buttons. That's still live. Can you aim that at that connector and show us what you're about to do? Yeah, all right, so guys, stay right there for a second, if you can hold still right there. What we're going to do, guys, is we're going to, because we can't back probe this, there's a grommet that's in his way to do it. We're going to put that pin that I just handed you, show the pin for me. Can you do that on the camera? Guys, see the pin? All right, there is always a concern if we're going to front probe a connector, that pin may be too big of a diameter, bigger than the male pin that's supposed to go in there. And what will happen is you'll spread that terminal, and then the male pin will never fit anymore. So it's real important when you do this test for me, all you're going to do is just touch the end of the pin where you can see a little bit of metal. You follow? So the female part, Dave, you're gonna touch that male pin to the female terminal, but you're not going to stuff it in there. You follow?
Yep.
Okay, that's what we're gonna do, and we want that white with a black tracer. See the white black? That white black tracer is going to be my computer heater control. I want a voltage reading on that first. And our key is still on. And you can, so you guys know what I'm doing there. Give me the camera back and I'll let everybody see the screen. All I'm doing here, guys, is I'm going to my, my lab scope, volts DC. I'm not going to use the voltmeter. We have a scope. The scope is a really fast voltmeter, so let's use it. And turn channel 2 off. Don't need to peak detect this. As far as settings go, we want to be on 20 volt. All right, so are you touching on that wire right now?
Right now.
And that's the white with a black, correct? Okay. We expected to see no voltage on this circuit. It's ground side switched and that wire is broken. So how do we test a computer driver that ground side switches that circuit with a circuit that's damaged? Is we're going to use a test light to do it. First thing we're going to do, guys, is we're using a test light to substitute the load of the O2 heater in the circuit, okay? Now the computer's pretty smart and it may not let us do it initially. We'll see the result of it. We may have to clear the codes. First thing is, touch this test light on this bolt and let's make sure the test light lights. Okay, good. And then I need to move your hand just sideways a little bit so I can, yeah, good. So that's how I'm, do it again. Okay, so you see when we find a ground, our test light lights. This is a ground side switch circuit. We're going to touch on the white with a black pin. Again, this is a test light. It's a lot fatter than that terminal. And I want you to touch on that terminal and we want to see if that light is lighting right now. And my guess is it will not be. It shouldn't be.
No.
Okay, next step is we need to start the vehicle and see if the light lights. You keep holding that on there. Let me hold that for you. So you have to hold the connector maybe with your other hand.
I'm good.
Okay.
Yep.
And don't jam it in there. We're just touching it.
Yep, got it.
All right. Make sure you're in neutral. Clutch in. Start the car. Nice. Okay, good. Shut it off. Did you guys see the test light pulsing on and off? What did that tell us about the computer driver for the heater circuit?
It's in pulse.
It told us, number one, that it's good, and number two, it told us it's pulse width modulated. Just to review here what we just did, and then I want to show you too what we're using to fix it. Guys, this is a 2014 model year vehicle, and we're right now in class, we're in sections 2 and section 3 in my material. And I'm talking to you guys that are watching this in hindsight, and I'm talking to you guys live, that I mentioned one of the focuses that I have for my class is to make sure I'm teaching you fundamentals. That what we're doing here is a 2014 model year, and it's the same thing I would do with a 1990 model year car as far as testing a computer driver and testing a circuit. Now there's things that I've shown in here that there are some concerns in doing and using a test light and checking a driver, but I know a few things we haven't talked about in this video or in this case study. That one, I know the current draw of an O2 heater is way more than my test light. So would my test light in any way, shape, or form overload the computer driver, or would that test light cause more current flow and damage the driver over top of what the O2 would normally do? The answer is no. My test light draws about 100 milliamps. My test light draws about 100 milliamps, and my O2 heaters, they draw around 2,000 milliamps. Does that make sense? So we're not worried about that. You saw that with that lighting, that tells us that control wire and tells us that driver's good. Now think back for a second. I said if that circuit was damaged to the point where we couldn't use the sensor to check it, which we can in this case. We could have just fixed the sensor and then see if the heater was working when we're done. The scenario I'm giving you is, what if it's so damaged you can't, and you have to sell this customer a $2,000 computer? This is the process you would need to do to check it. You use a test light. We saw that test light. We also saw it was pulse width modulated. Says that that circuit is fine. Sell the O2. We're good to go. Well, all we're going to do for our fix, we can't really repair O2 wires with solder. They don't solder well, whatever they make them out of. So what you use is a heat shrink style butt connector. We're going to cut out the damaged piece. We're going to reattach it and crimp it, and then when we seal it, we use a lighter. And this is the good kind. What comes out of it is there's almost a sealant that melts on the inside and oozes out and completely watertight seals the connection. So this would be the right fix, is a heat shrink style butt connector. And I don't know where Karen gets these. I buy them at Radio Shack is where I've bought these before. So these are the proper way to do it. So fix that, and then I'll show you the one final test that you can do in seeing the signal. Actually, it's really not even necessary. The main point with this is our heater circuit pulsing that was good. If we were to do this with a voltmeter, and I'm not going to show this because of time. If we were going to do this with a voltmeter, what we would have seen is this signal, this square wave right here. This on-off control. The high-low signal telling us it's pulse width modulated. If we fixed the wiring and checked the circuit and saw that, what would that tell us about the driver? It's good. That's our concern, right? So you dodged a bullet. Let's fix this wire and be a little careful next time with where you're running a wiring harness. All right, so knowing me, you guys have been following me long enough. You knew I was going to do this. I had to show the final part. I'm not going to show you the connection. I'm just back probing the O2 on that heater circuit. Go ahead and start it. And that is frozen. All right, shut it off. My scope is frozen here. I need that to be live. And it got kind of crazy on me here. Hang on. Why am I reading negative voltage? Am I on battery positive or battery negative over there? Is that on negative?
What do you want?
I want to be on negative. That shouldn't be reading that. But I don't think it's the car. Why am I reading negative voltage? You sure that I am on battery negative?
Yeah.
What the heck?
Yeah, you're on battery negative.
Sometimes when this goes into hibernate mode, I'm doing something wrong. What is it? Oh, ha! Look, I hit invert. Did you see that? See, I gotta pay attention to what I'm doing. Did you see that?
Yeah.
I had invert. That's my own dumbass fault. Okay, so yeah, don't hit invert when you use the scope. Good lesson. Okay, so that's what we really expected to see with the circuit not being turned on, although I'm surprised that the computer's sending power to this, or the relay is supplying power to this circuit. Go ahead and start it. I mean, unless I'm on the wrong wire. Guys, listen, if you were using a regular multimeter, what you would see on this ground is right where my finger is 10 volts. 10 volts. You would think you had a bad ground. Can you guys see that number right there? 9.95, 10 volts. I mean, it's a good lesson on the average reading meter. It's a good lesson on pulse width modulation. We'll be doing more pulse width modulation duty cycle control here coming up later in section 3. That is a fix, no question about it. Last thing we'll do with this Subaru is we'll clear the codes and be happy there's a no-cost fix. One more thing is Dave was willing to be the poster child of what not to do when you change your exhaust but he learned a good lesson. It didn't cost him anything. So thanks for helping me, Dave. Really appreciate it. And you know, my viewers and everyone else, thanks you for a 2014, which is the newest car we've worked on yet. So nice, man. Thank you.
You're welcome. Thank you.